All right, so happy Friday and welcome to Set Theory. This is getting into probability. It's a little bit different, and I want to kind of show you this unit, and you'll see this format a couple of times before we get into the next lesson on probability, because I really think it sets you up for success in understanding and comprehending the content and also why it works the way it does. This is also just a little bit better, more visual than instead of just all abstract thinking, kind of like the last one was. So, a set is just a collection of elements, okay? And that elements could be colors, it could be people, it could be numbers, all sorts of stuff like that. And you remember when we were solving for solutions on quadratics, we would write them as a set. So we write them with these brackets, and we write them separated by commas, and we write them with a bracket like that. So that is the set. So if you have a universal set, that is the set with all possible elements. Okay, so we could say for single digits, right? We could say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm separating those with commas, and then closing it with a brace as well. Okay, so then we can have a subset. We could have a set within the elements from the universal set. So we could say single digit, let me put set within universal set. So we could say single digit even numbers, right? So that will be 0, 2, 4, 6, and 8. So that will be a subset of the universal set, right? There's more in there. There's more possible, but those are the only ones that we're looking at. So that's what a set is. We're now talking about the relationships between them. So if we have an intersection, that is the elements two sets have in common. Okay, and the big word we use for here is and, okay? I want you to focus on that word and. The symbol for this is kind of like a upside down, it's just like an arch, I guess. A lot of times it'll look like an N, but it's just an arc. Okay, so if we're talking about and, it's the elements that are in this set and another set. So if your sets are C and D, the intersection between them would be 7. 7 is present in both of them, right? So the C and D is how you would read that. C and D would just be 7. Right? So then union would be the elements from both sets. And you never repeat these, okay? So don't repeat. The union from both sides. So think of this as or, and this one is the exact opposite. It's just a U. Okay, so think of union as or. If we have these same examples, 7, 8, and 11, the union would be 7, 8, 11. We're putting all of the elements from each set, and we don't repeat them. You see 7 was in there twice. We're not going to repeat it. So think about it. I could ask you the question, is 11 in C or D? And you would say, yes, it's in D, right? It's in either one of them. I could say, is 5 in C or D? And you would say, no, it's not in either of them. So kind of or and are really what you're thinking of. Is 7 in C and D? Yes, it is in both of them. Is 11 in C and D? No, it is not. It is only in one. Okay? And then we have complement, which is exactly what we had before. This is not, okay? So this will be elements. And this is the big thing, okay? I'm going to change the colors. This is elements from the universal set. Not in that set. Okay, so pretty much the complement could be anything else, right? The symbol for this is either a tick mark, right? So I could say like the complement of A like that, or sometimes you will also see it above. And I'm actually going to put this little thing out here as well, because sometimes you'll see it like that. Okay, that was what we saw yesterday. So if our example is all the universal set right here, you see it says U. The universal set is all single digits. And then A is 2, 5, 7, 8, 9. Well, the complement of that will be everything that's in the universal set that is not in A. So that'll be 0, 1, 3, 4, and 6. Those are the 5 numbers that are not in A. Okay, so as an example, a large bag holds marbles of the following colors. A small bag holds marbles of these colors. So to find the universal set, what we're going to do is we're going to label this as U. And I'm just going to use the, the first letters of this. So we have blue, green, orange, pink. And then we need red. We already have green. We need yellow. And we already have orange. So we don't write green and orange again. We just write them out like that. So then define the 2 subsets of this universal set. So for the large bag, we have blue, green, orange, and pink. And for the small bag, we have red, green, yellow, and orange. All right, so we're going to draw a Venn diagram. And this is why I really like this packet. This is why I decided to use it. I'm going to make that a little bigger. So this can be the large bag, and this can be the small bag. Small bag. Okay, so in the large bag, we have blue, green, orange, and pink. In the small bag, we have red, green, yellow, and orange. So the 2 things that are in both of them are green and orange. So we need to make sure we put it in the middle, the intersection of the large and small sets. And then for large, we have blue and pink over here. And then for the small, we have red and yellow over here. All right. So then find the intersection and union of the subsets. So if we have large and small, this is the intersection, we would say green and orange, okay? And if we would have the union, which is large or small, then we would have all of them: blue, pink, green, orange, red, yellow. Now, let's say, for example, there was what's another color that they didn't use? Let's say there was a white marble that was outside of the bag. Okay, so that wasn't in the large bag or in the small bag. It was taken out and it was just set off to the side. So that white marble right there would still be a part of the universal set, but it would not be part of the union of the 2 since it's outside. Okay, so sometimes you can have things by themselves that are not a part of a subset, but is still a part of the universal set. And you'll need to use those for the complements, okay? So we're going to go down and do this next one. Suppose the universal set consists of all the single-digit positive whole numbers. 2 subsets are created, the set of all even and the set of the multiples of 3. So I think you're going to see a couple of those here that I was just talking about. So maybe I didn't even need to explain it. So the universal set is going to be single-digit whole numbers that are positive. All right, so to define the 2 subsets, we have even. So we're looking for all of the even numbers, which is 0, 2, 4, 6, and 8. Yes, 0 is even, look it up. And then for multiples of 3 would just be 0, 3, 6, and 9. Okay, so when we will draw a Venn diagram to represent these sets. So we have here, let's call one even and call one the multiples of 3. So the ones that are even and multiples of 3 would be the intersection, right? So that would be 0 and 6. And then the other multiples of 3 are 3 and 9. The other ones that are even are 2, 4, and 8. Now that does leave some other numbers, right? So 1 is out here, 5 is out here, 7 is out here. None of those fall into either even or multiple. So this is what I'm talking about. It's still in the universal set, but it's not in either of those subsets. So we're looking for the complement of E right here. In other words, what is not in E? So that does not only include 3 and 9, but it also includes 1, 5, and 7, right? So 1, 5, and 7 are not in E, correct? So we need to list those. 1, 3, 5, 7, 9. So sometimes it's really easy. Obviously, that's just which ones are not even, but sometimes it's which you would be able to tell me off the top of your head. Sometimes it's really helpful to draw a Venn diagram so you can visualize it and see it. So the intersection of E and M would just be 0 and 6. And then the complement of the union of E and M. Okay, so first off, we need to find the union of E and M to be able to find its complement, and that would be 0, 2, 3, 4, 6, 8, and 9. So that would be the union of E and M, but to find the complement of that, we would just figure out which ones are not there that are still in the universal set, and that is the 1, 5, and 7 that I was mentioning to you. Okay, so when it comes to this practice right here, I think you'll be fine with these names, but I do want to come over here and help you out with the letters. This one is always one that throws people for a loop, so I'm going to help you out here, okay? So create a Venn diagram with 3 sets using these letters. So we have the letters in America, and we need to figure out whether these letters are in all 3 of them. We have America, Cambodia, and Denmark. So America would be A is in all 3 of them. M is in all 3 of them. E is in America and Denmark, so we need to put the E here. R would be in America and Denmark as well. I is in America and Cambodia. And then we've already got A. Okay, so America's good. Now for Cambodia, we need C, which is in America and Cambodia. Did I skip over C? I think I did, yeah. Okay, so now we have A-M-E-R-I-C-A. Yes, so now we're good. As long as I can spell it with the words that I have and don't miss any letters, I'm good. So C for Cambodia. We already have the A and the M down. B is only in Cambodia. O is also only in Cambodia. D is in Cambodia and Denmark. I and A. So now can we spell those letters? C-A-M-B-O-D-I-A. All within the Cambodia circle. We're good. All right, so the things we need for Denmark, we already have D and E. N is only in Denmark. And then M, A, R, and K is only in Denmark. Okay, so that is our Venn diagram right there. So now that should help you out. All we have to do is list them. So list the elements of A union D. That will be what's in both A or D. So that will be A, M, I, C, E, R, D, N, and K. All right, I'll just keep going and do a couple of others. How many elements are in the complement of D? So in other words, what's not in D? And it's just asking for how many. So technically it's 4, but I'll list them. I, C, B, O. All right, and then list the elements for A intersection C, but the complement of that. So A and C would be this right here. Okay, so that's A and C. But we want the complement of that. So we want everything that's outside of that. And that would be E, R, N, K, D, B, and O. All right, and this is what elements are in all of them. A and C and D, that's pretty easy to see. It's just A and M.